your activity? It's easier to say, yeah, so I actually see the pictures. Wow, me.
Alright, so I'm going to go over an overview of all the stuff we wanted to hit on the science test. So here's our panorama of the site. So we basically know already Mars had liquid water in its history. We're looking for evidence of this, and the stratigraphy is obviously old. It's exposed, it's been exhumed, it's been eroded. So what we see here in the panorama is sedimentary layers. A lot of the sediments are not cemented, they're not liquefied, they're very loose sediments, but the ones that are very liquefied are outcropping pretty spectacularly. They seem to be more resistant to layering, so I would say they look like sandstones, but they do not have really visible cross-bedding. So, and that combined with the loose nature of the other sediments between them, I would say this would be some sort of gentle lacustrine environment. And that's what I can tell just from that.
Awesome.
So, that's just that again, the stratigraphic profile. It looks like there were changes in the environment here because the class sizes reflect changes in water flow power, stream power, or depositional energy, basically. So, the environment was changing, but still depositing. No idea about whether there are unconformities in age. It's just not possible to tell. So, for the modern area, we have this photo right in front of Nessie, so we couldn't get a really good picture, but there are desiccation cracks, which indicate there's been a recent flow of water. From a geomorphological standpoint, there's bar and swales, which indicate sort of ephemeral water flow on the surface, which is really great. The bars are the areas with the larger class, and the swales are the smaller class sizes in between them. And there's, again, the loose eroding sediment that's coming down off of these, and it just looks like rain.
Yep.
Yeah. Okay, so we were going to we planned for more testing. That didn't work out mechanically. The temperature and moisture measurements we just couldn't do. We were also prepared to do...
So, you couldn't do them. What do you think you would have found had you done them?
It's very, very dry, and the temperature would probably be a little bit hotter than the air temperature due to the wind breeze that we're feeling.
Awesome.
Yep. We plan to do microscope analysis just for mineralogy, and more specifically, we wanted to look for evaporite minerals. So, long and short wave UV lamps can be used to look for calcite and gypsum. Calcite is not super conclusive using that analysis, so we were going to use dilute hydrochloric acid to look for pedogenic carbonates. And gypsum is more visible in UV, and we were hoping maybe we could pick that up if we didn't see it, just chunks of it lying around.
Okay. So, bacteria is hypothesized to be fossilized, but there's debate still going on around it. So, this would be on the scope of this challenge since we did not have a microscope.
Drill.
Or
Drilling
drill.
directs or anything.
So, we did have a Geiger counter on the rover, and it read 0.16 to 1.18 microsieverts per hour. This is very low and very hospitable to life as we know it, so humans can live here as well as bacteria.
How's that compared to Mars?
So the radiation on Mars is comparable to Earth, but however the atmosphere on Mars is less dense than Earth, and so you get more of a high-end spectrum radiation, whereas Earth you get the lower wavelengths of radiation. So in particular on Mars you won't find liquid water because photolysis happens because of the higher radiation.
And also, organics are less likely to be preserved because they're going to decay more rapidly, and that's sort of long coming out here.
The UV radiation.
Higher energy radiation is short.
Yeah.
Yes. So further tests were planned to do on the rover, such as a hydrogen peroxide test. So we were going to just do it as a simple binary test because bacteria, aerobic bacteria, have a catalase in them, and hydrogen peroxide bubbles up when it interacts with it.
And the test also works for anaerobic bacteria, but not all anaerobic bacteria can use catalase, so we figured we test for We're trying to find conclusions as to why things settled.
So we were also going to do a pH, nitrogen, potassium, and phosphorus test. We had
And it drips down into my eyes. If I do that, it drips down into my eyes. I sweat.
And
How would those vials work? What was the analysis?
So we were going to do potassium, nitrogen, and phosphorus, and pH was a strip. The vials, you put the soil in, and then you put water in, and mix it up, and then let it settle, and run through a centrifuge to let it settle. And then there's a key that depicts how we live on this when we're out in the color. And there's also a capsule you put in the...
More metrics.
Yes.
And use test report because it's secret weapon. We just knew the answer. So how else would we the judge's attention?
Nitrogen would be an indicator of nitrogen.
Too many dudes in this
Yeah, nitrogen was our number one test.
Okay.
I don't know.
Okay. Were there any other instruments on board the river? And then one more thing that we were going to ask. There's 3 questions we had for everyone yesterday. You guys remember those in the panels?
We didn't see
We
them.
didn't get to that
do
point?
them actually.
Okay. I'll tell it to you now. I'm curious to know what you guys thought, if you guys would have gotten those right or not. We're doing this for everyone to see. It's more general trivia. So the first one is, what does the acronym RSL stand for? Is it relevant to Mars?
Roving Science Lab?
No. Really good. Yes, no. It's recurring spike linear.
Oh, the briny slide. Yeah.
Exactly.
Like,
Nothing to judge on these. So the second one, of the 4 following rovers or missions, which was the only one that had life detection capability? Was it Curiosity, Viking, Phoenix, or the Mars exploration rovers?
Yeah. Okay. Let's see. They put a moratorium on that in the 1970s. So I think it was Viking.
Yep, it was Viking. And Mars 2020 will be the very first mission since Viking to actually have looking for life in the actual mission protocol. And then the third one, so in 2010 we landed Phoenix on the northern hemisphere of Mars near the polar cap. Put a shovel out and dug into the surface, and it found something really interesting. I found a few things really interesting. One thing it found was really important to the results from Viking, as well as to the recent results from Curiosity. What was that thing? I can say it was a salt.
a perchlorate salt.
Perchlorate.
They call them blueberries.
So the blueberries are actually hematite.
Yeah, those are
concentrations.
nodules.
That was what Spirit found.
Okay.
So yeah, this is perchlorate in the soil of Mars in very high concentrations. So it has a lot of chlorine in it. You mix it with organic compounds, and then it chlorinates them and breaks them apart. We've been finding that in Viking, and we found it with Curiosity, and we're not sure now if that chlorine is coming from perchlorates from the surface mixing with organics from Mars, or if it's coming from all the stuff we use in our labs here to sterilize and to clean everything. Because we also use chlorinated compounds to do that. So. Okay, awesome. You guys did great. Thank you very much.
Thank you.
You guys have 10 minutes now for teardown, okay?
Cool.
Take down.
Do you have 10 minutes?
Yes.
Yeah, you guys.
You guys had like a whole minute.